if you can recall, before this, I've mentioned a few times that the Laplace of the two functions that are multiplied to each other, for example, t cos t, it is not equal to the Laplace of t times Laplace of cos t. Okay, cannot be done this way. And this is also applied to the inverse Laplace transform. But there are actually a theorem related to the multiplication of two functions here, which is called the convolution theorem. Okay, which is what we are going to discuss now. So the convolution theorem says that the inverse Laplace to the f times g is equal to the integral from 0 to t fu times gt minus u. Okay, so this theorem is given in the table of Laplace, so you don't really need to memorize this one. Okay, so in the table you will see the convolution theorem is, where's the convolution? Here. Okay, the last one here, the last line here. So this is the convolution theorem. So in the convolution theorem, we need to get what is the f and what is the small g. Okay, so we know that the inverse to the fs is ft. So similarly, the inverse to the gs, of course, gt. So if we know what is our ft, we just substitute t with a u, then that's the fu term. If we know the gt, then we can simply get, okay, gt minus u. Okay, so the task is to get ft and gt first, and the next step is to solve the integral. Okay, so the convolution theorem, the difficulties to the convolution theorem most likely is in solving the integration. Other than that, it's just straightforward solution. So in the example 22 here, okay, the question states that find the inverse Laplace transform for 1 over s times s squared plus 4 using convolution theorem. So it means that we want to get the inverse to the 1 over s squared plus 4. So we can see that the expression that we have here actually can be written in the form of partial fraction, right? Where it is equal to a over s plus bs plus c over s squared plus 4. So you can see if you have the fraction like this, you have two choices. You can solve by the partial fraction, or you can solve using convolution theorem. Okay, but if the question specifically asks for the convolution, then you need to do the convolution. Okay, so let's see the solution by the convolution now. All right, so by the convolution, so we are going to see the fs to be 1 over s, okay, because this term here is actually 1 over s times 1 over s squared plus 4. Okay, so the first term is the fs and the second term is the gs. So fs equals 1 over s, so therefore ft is the inverse to the 1 over s. Okay, so the inverse to this is 1. Okay, if we refer to the table, the inverse to the k over s is k. So we have 1 over s, so it is 1. So in the theorem, it is fu. Okay, so since we know our ft, so we can simply state therefore fu is also equals 1, because in the ft we don't have the term, the variable t. So regardless the value of t, the answer is 1. Okay, compared to this one. So if ft equals 1, then fu is also 1. But if your ft, for example, equals t minus 1, then fu would be u minus 1. Okay, so make sure you can understand this. So that is our fu. And then write our gs to be the second term, which is 1 over s squared plus 4. So therefore, gt is simply the inverse to the gs, which is 1 over s squared plus 4, which can be written as s squared plus 2 squared. So at the top it should be 2, but in order to get 1, we need to multiply with a 1 over 2. So this is simply 1 over 2, and then the inverse to the 2 over s squared plus 2 squared is sine 2t. So this is our gt. Okay, 1 over 2 sine 2t. But in the theorem, we need to have gt minus u. Okay, so therefore gt minus u is simply 1 over 2 sine 2t minus u. Okay, so put things together. Therefore, by the convolution theorem, the inverse to the 1 over s squared plus 4 equals the integral from 0 to t fu, which is 1, okay, times gt minus u, which is 1 over 2 sine 2t minus u du. So basically, we just integrate sine 2t minus u with respect to u. The common mistake that the student did in the exam is integrate with respect to t. That is the very common mistake. Okay, so you need to be very careful in the convolution theorem. The integral that you should do, okay, is basically with respect to the u. You integrate with respect to u, not with respect to t. Okay, so please highlight that part. So we have 1 over 2. Integrate the sign would be negative cos. So negative cos 2t minus u, but don't forget we need to differentiate 2t minus u with respect to u. Okay, so we have over negative 2, not positive 2, because we differentiate with respect to u. Okay, so negative 2. And then we evaluate this from 0 to t. So the 0 and the t need to be replaced in u, not in t, because originally we integrate with respect to u. So we have 1 over 2, in fact, negative 1 over 4. Okay, we can take out negative 2. In fact, we can cancel out negative and negative. So we have positive here, positive 1 over 4. So in the bracket, we are going to have u equals t. So we have cos 2t minus t, which is cos 0 minus cos 2 when u equal to 0. So we have cos t. So cos 0 is 1. So we have 1 over 4, 1 minus cos 2t. That's it. So that's the convolution theorem. Okay, so this one seems very straightforward because the integration that we have is pretty much straightforward. Okay, but in other cases, the integration that we have might be not quite straightforward. Okay, we need to do a bit more of manipulation. So again, the difficulties most probably comes from solving the integration part.